Hello, this is part 2 of section 2.6. In the previous video, we ended the lecture talking about how certain and compound linear inequalities can be rewritten as a double inequality. For example, negative 5 less than or equal to 4x minus 1 and 4x minus 1 less than 7 may be written as negative 5 less than or equal to 4x minus 1 less than 7. And the main reason why we can do this is that these two pieces match each other. If those did not match, we would not be able to rewrite it as this double inequality. One way to solve this style of inequality is to rewrite it as two inequalities and then proceed as above. Alternatively, we can perform the same operation on all three parts of the double inequality with the goal of isolating the variable in the center. Graph and write the solution in interval notation. So here we have negative 4 less than or equal to 3x minus 7 less than 8. First thing I want to do is get x by itself, so I'm going to add 7, but now instead of just adding it to two sides, we have to add it to all three sides. So we get 3 less than or equal to 3x less than or equal to 15, and last but not least, divide by 3. So you get 1 less than or equal to x less than or equal to 5. Now the nice one about these that can be rewritten as double inequalities is that we only need one number line again. Because I know this goes from 1 to 5. Oh, I added an equal sign here. Let me erase that. And then we have a loose inequality, so a filled circle at 1, a strict inequality, so an empty circle at 5, and then everything between. And then in interval notation, it's 1, 5, with a bracket on the 1, a parenthesis on the 5. When solving a compound inequality with the word or, we are looking for all numbers that make either inequality true. So one or both of them. To solve a compound inequality with or, we just start as we did above by solving the two inequalities. Then we find all the numbers that make either inequality true. Example 5. Solve 5 minus 3x less than or equal to negative 1, or 8 plus 2x less than or equal to 5, following the steps. Step 1. Solve each inequality separately. So for the first inequality, we're going to subtract 5 from both sides. Get negative 3x less than or equal to negative 6. Then we have to divide by negative 3. And we get x. Oh, we divided by a negative, so it'll be greater than or equal to 2. And then subtract 8, 2x less than or equal to negative 3. Divide by 2, x less than or equal to negative 3 halves. Step 2 is to graph them separately as we did before. So we have x greater than or equal to 2, x less than or equal to negative 3 halves. So make sure I got all that right. Yep. So x greater than or equal to 2 would be this graph with a filled circle at 2 going to the right. X less than or equal to negative 3 halves would look like this with a filled circle at negative 3 halves going to the left. Now this is where it gets different. If this were an and inequality instead of an or inequality, there would be no solution because neither of these overlap. Sorry. But because this was an or inequality, we aren't looking for where they overlap. We are looking where either is true. So we kind of just smush these two graphs together into a single graph. Write the solution set of the compound linear inequality and inequality in interval notation. When writing the solution to an or compound inequality in interval notation, we'll often use this union symbol U to show the union of the solutions shown in the graphs. So in inequality notation, we get x less than or equal to negative 3 halves, or x greater than or equal to 2. In interval notation, it's negative infinity, negative 3 halves, with a bracket on the negative 3 halves, union 2 to infinity with a bracket on the 2. Example 6. Solve 2/3 x minus 4 less than or equal to 3, or 1/4 x plus 8 greater than or equal to negative 1. Graph and write the solution in interval notation. So first thing I'm going to do is solve each inequality. There's a fraction here, so I want to get rid of the fraction, so I'm going to multiply everything by 3. Do not forget to use your distributive property. So we get 3 times 2/3 x minus 3 times 4 less than or equal to 3 times 3. Reduce first, then 1 times 2x is 2x, 3 times 4 is 12, 3 times 3 is 9. And now we solve as normal. And we end up with x less than or equal to 21 halves. Now let's solve the second inequality. Go and multiply by 4 on both sides. The 4's cancel out. We get x plus 8 greater than or equal to negative 4 minus 8 minus 8, x greater than or equal to negative 12. Graph them separately now. For x less than or equal to 21 halves, we get that graph. For x greater than or equal to negative 12, we get this graph. And now we want to combine those together. Well, we actually just get this graph. If I smush those two lines together, they are going to overlap, but then I'm going to get arrows going in two directions. So our answer is going to be negative infinity to infinity, or all real numbers. And that's the end of section 2.6.